Okay, students, here is kind of a thought process slash kind of tutorial on designing your cams the best that you can. So here's how I'm going to do this. This is kind of my robot that I have shown. What I want to happen is this robot starts in a down position. When it raises up, it places a pretend cube right here, and this scale tips. So that's what I want to happen. So for right now, I'm just going to focus on this robot and its kind of cam profile. I want the robot to start right here. And this little hole is what I've determined to be the place that I'll have a peg going through, and my follower will push up on it. So I'm going to measure and say, right now, this is kind of what I'm okay with for it being in this position. So I'm just going to click, say, the circle. You might click some type of other feature on yours, and you'll be fine. Here, I'm finding out that when I go to measure, and I'll show you measure this again. I'm going to measure. I'm going to click on the circle. Again, for you, it might be like the bottom face of something. And I'm going to click on the top of my box. Now, I don't want to use this 1.4 because that's not always perfect. But I want to click on delta. In this case, the y dimension is 1.45, which is fine. And this is what my starting position is going to be, or my length of the follower from the top of the box to about the center there. And if we're off a little bit, it's not too bad. I mean, if we're off like a 1/16 of an inch, that's so minute, it doesn't really matter. So 1.450. I'm going to go back to this document that is going to be available to you, and there's going to be one called the follower height. This is going to be 1.450. Let me double check here. Yep. And that's going to kind of be the start of my follower. That's at 0 degrees. That's like 0 degrees is the smallest it's going to be. Then the maximum displacement follower is going to be 180. So now what I'm going to do is I'm going to take this and just kind of play around my constraints. This is going to be about level. And I kind of want it to be up there. So that's going to be its highest motion. So I'll grab the measurement tool again, select here and the top, make sure I check my y distance, and that is 2.681. So over here, 2.681, and that's going to be my follower height. Wonderful, look at that. That's my lowest, that's my highest. Now, what I want to do is say, okay, what kind of motion do I want? Do I want like a real jerky motion up here? So like very quickly raises, or do I want like a nice smooth motion? And for me, I've kind of decided I want like a nice smooth motion, which means that between each integral here, I want to increment it nicely. So to do that, you're going to do a little bit of math. So here's what this math will look like. I'm going to just want to give like a little area here. I'm going to take the difference between these two numbers right here. So I don't want this to be grabbed by anything, so maybe I'll go over here. I'm going to say this equals this minus this. So my maximum minus my minimum, which is 1.234. And I'm going to divide this because there's 1, 2, 3, 4 spaces technically to get to f. I'm going to divide that by 4. So I'm still in this box. I'm going to put this in parentheses, and I'm going to divide this by 4. So I have this number 0.30775. I'm going to go in here, and I'm going to say this is going to equal this number plus that number I calculated. And I'm going to do the same thing here. This number is going to equal this one plus that number I calculated, and this one is going to equal that previous number plus this number I calculated. Now, if I were to go ahead and just for checking, if I say this number plus this number, I should get 0.2681, which I do. So it means I did my math right. So now, so far, my height of my follower is just linearly, has a constant slope moving up to its height, and then going down, well, really, it's just going to be the same thing. So this is going to be 2.37325. This is going to be 2.0655, 1.75775, and 360 is the same as the other one, 1.45. And that's going to be the height of my follower. for my first cam. And you can rename these to figure it out. And right now this is kind of doing its own thing, which we can come back and fix this later. But now what I want to do is I want to find what the radial dimension of my cam at each one of these spots is going to be. For this portion, what I am going to suggest is that this number right here can't be anything lower than 0.25. If you do 0.25, you know, that's fine. That's actually an okay place to start. But for me, what I'm going to do is, because I start my follower height at 1.45, I am going to say this is going to equal this minus 1. Essentially, I'm going to take my my follower and I'm going to shrink it. I'm going to take my radial dimension, I'm going to shrink it down so it fits within my box. So when I minus 1, that means this. Instead of my cam being all the way up here, hitting this, it's going to be 1 inch down at 0 degrees. And that is 0.45 inches. So that means from right here, going up, it'll be about a ½ inch up. And then I can just edit my follower to be the correct length that I need it to be. Essentially what it will be is the 2.5 from here is going to be, we're going to take 2.5 minus this plus this. And that will be like what your true follower will be. And I might have another video for that. So now I want this to be constant all the way through. And when I bring that all the way over, I will now have a shape of my cam with the coordinates. So 0 degrees is 0.45, 45 is 0.75, so on and so forth. You might not be able to minus 1 because of your distance. So you might just minus like a half. Again, you don't want this number, your smallest number, this might be your smallest number depending on what kind of cam setup you want. You don't want your smallest number to be anything less than 0.25. So if that's the case, you just have to minus a constant number of something else. Like I could have gone through, and if I wanted this to be 0.25, I could have set this up to minus 1.2 all the way across. And if I did that, I'm at 0.25, I go all the way across. I just have the same cam, but a smaller version. So you can see there's a little bigger, a little smaller, a little bigger, a little smaller. Nothing really changes all that much. So that real quick tutorial on making your cam with just a minus of 1 to shrink it down so it's not as big as the box, which is a great place. You might only be able to minus a half. You might have to minus 2 inches to make it fit within your box. But essentially, you don't want anything too large. Like 0.45 and 1.6 is great. So now that means from the center of here, my cam's largest dimensions will be 1.6. If it's 2.5, it is going to hit the top of the box, and that cannot happen. So you cannot have anything greater than that. So now with this, you will go back and you will use the numbers angle of rotation and radial dimension of cam to plot out your points and plug that in. So here's one of my cams, this one. If I go into the sketch, all these little points are points that I use the polar coordinates for. Put them into place, made my 0.25 at the origin, and I put a interpolation spline and extruded it out. And I have my cam. So, hey, quick tutorial on that. I will have a tutorial in future ones.